Ever feel like your Azure cloud traffic is stuck in a confusing digital traffic jam? You're definitely not alone. In this complete course, we are going to completely demystify Azure Virtual Network routing. We'll take you from understanding the basic built-in maps to building custom security detours and even setting up a smart, self-updating GPS system for your network. By the end, you will be the ultimate cloud traffic cop. Stick with me through all 4 sections and let's master VNet routing together. Imagine Azure as the landscape and a virtual network as your city's infrastructure, with virtual machines acting as the office buildings and the VNet providing the roads. Azure VNet routing facilitates delivering data from point A to point B, whether it's another building in the same VNet, a remote warehouse in another country, or the public internet. Without routing maps, data gets lost. Azure provides a default built-in map, but you have the power to redraw the roads, creating detours for mandatory security firewall inspections, corporate compliance logging, or to create database shortcuts for efficiency. When you build a subnet in Azure, it instantly lays down an invisible GPS map called system routes. This default routing behavior guides your data exactly where it needs to go. Internal traffic happily travels along local roads without ever leaving the virtual city. Unspecified traffic takes the highway directly to the public internet, while any requests heading to unroutable private addresses hit a brick wall and are safely dropped. Finally, Azure automatically adds new routes so both IPv4 and IPv6 traffic can seamlessly navigate together. Azure's default routing map handles basic connectivity, but sometimes your cloud infrastructure demands stricter security. Imagine a bank needing to inspect all outgoing data to prevent leaks. To enforce this, we introduce a network virtual appliance, such as a dedicated firewall. By utilizing user-defined routes, you can manually redraw your network's map. Just create a custom route table, define a rule forwarding traffic to your firewall, and associate it with your subnet. Manually updating network maps is a trap. It is slow, unscalable, and highly prone to human error. Enter BGP, the GPS of the internet. Just like a smart navigation app on your phone, BGP constantly communicates with other networks to automatically recalculate routes when changes happen. In Azure, you can implement this dynamic routing 2 ways. Use VNet gateways to instantly bridge your physical office to the cloud, or deploy an Azure root server to act as a central cloud translator for your virtual appliances. Both options instantly update your routing tables without you ever having to lift a finger. When multiple routes point to the exact same destination, Azure acts as the ultimate traffic cop. It resolves route conflicts using 2 unbending rules. First, specificity wins. Under the longest prefix match rule, the narrowest and most specific network path is always chosen. But what if 2 competing routes are equally specific? Azure applies a strict hierarchy of authority. Human-made user-defined routes take the gold, dynamic BGP routes take silver, and default system routes settle for bronze. Our course explored how Azure built its default routing map, which automatically guided internal and internet-bound traffic. When our network required stricter security, we manually redrew those paths using user-defined routes to force data through virtual firewalls. To eliminate tedious manual updates, we then implemented BGP, which dynamically calculated new routes for us. Finally, we saw how Azure acted as the ultimate traffic cop, seamlessly resolving conflicts by always prioritizing the most specific and authoritative rules.